2, 1, and okay, everybody, hello. We are back, and I'm here with Antonia, who is going to be doing a workshop with you, and she'll introduce all that. The way that this next hour is going to be is we're running about 10 minutes over, which is fine. And so we've got 20 minutes of workshops, and so we've got 3 times 20 minutes of workshops, all on different things. And so Antonia is going to be our first one, and I'm going to hand it over to you. So I'm going to go. See you later.
See ya. Bye, Mark. Thanks for the introduction. And hello, everyone. Really, really happy to be here with you today. So I want to talk all about hand tracking today and how you can add hand tracking to your, oh, that looks a bit funny. Does that look okay for everyone? If you just type in the chat, yes or no, if that's looking okay, because it looks kind of weird for me, but as long as it looks okay for you, then that is fine. It's flashing, yeah, for me too as well. Okay, let me just stop that for a second. How strange. I don't want to give anyone a seizure. Perfect. There we go. Not sure why that happened, but there we are. Hopefully that looks okay. It's looking okay for me now as well. So yeah, so I want to talk to you today about hand tracking, why it's useful, what the benefits are, and also just give you a very practical demo of how you can incorporate hand tracking into your own projects if they're built in Unity. So my name, for context, is Antonia Forster. My pronouns are she, her. And my role is that I'm an XR technical specialist at Unity. XR, I'm sure many of you have heard the term before, generally is used as an umbrella term to cover virtual reality and augmented reality. So I specialize in both of those technologies and on creating demos and also empowering other people to use those technologies. And I have a specific focus on industry, but the demo I'll show you today will work no matter whether you're developing a game, an industrial application, or anything else. So this is broadly the agenda for my talk today. First of all, I want to explain what the benefits are for hand tracking in your application, why you might consider using it. I'll talk about some benefits for VR and AR specifically, but also some benefits for other applications that maybe aren't to do with VR and AR. Then I want to show you some of the different hardware options. So what you need to buy or obtain or borrow in order to use hand tracking in terms of hardware. And then I want to show you a couple of case studies from industry and also one from gaming about how you can use hand tracking to give you some ideas of what you might want to do. And then finally, once you have all that information, I'd love to just show you practically how you get started and how you bring that into your project. So I'm really curious here how many people actually have experience with Unity or know what Unity is. So just type in the chat, yes, if you either know what Unity is, what it does, or if even better, if you have experience with it, or no, if you've got no idea. And that helps me to kind of pitch my talk at the right level. A couple of yeses, that's great. This is a shot, if anyone doesn't know, from the Unity editor. So this is quite a familiar view for anyone who is. Lots of all yeses. Someone says Unity is an extension of my body. I feel that. Okay, mostly yeses and some nos. So I think it's worth just explaining. If you haven't seen or used Unity before, then this is what the editor looks like. This is Unity's kind of core product. We do have other things, other specialized tools, but this is kind of the core platform. It's essentially a 3D development platform. It has built-in lighting and physics, and a lot of people use it to make games, and you can use it to make virtual reality and augmented reality applications, but you can also use it for non-VR and non-AR. You could use it for mobile gaming, for traditional PC games. And also you don't have to use it for making games at all. In fact, what I specialize in is how people use Unity in industry. So we'll see in this talk that there's a really wide range of use cases. Now, what's interesting is if you haven't created VR or AR experiences in Unity, but you've used it for more traditional content, actually using it to build AR or VR content is not very different at all. You usually just need a couple of packages or a couple of extra tools. And if you have characters or environments in an existing project in Unity, you can usually bring them into VR and AR projects very easily with just a couple of clicks. So that's great news, hopefully, for any Unity developers out there. But if you are using Unity to develop your content, why would you want to use hand tracking? Well, again, to be clear, hand tracking solutions in combination with Unity can be used across a wide range of cases. So a lot of you here create immersive content, VR and AR, but you can actually use hand tracking with any kind of human-machine interface. So for example, you could use a controller like this one here. This is the hand tracking controller I'm going to demo at the end of this talk. You could use it to add interaction to a movie poster in the street or a piece of artwork. Or you could allow a user to interact with like a touchscreen kiosk or supermarket checkout without having to actually touch the surface. And that has some really obvious benefits in terms of hygiene and consumer confidence, especially now during a pandemic. But especially in the rest of this talk, I want to focus more on VR and AR in particular and what the benefits are there. So the first is that hand tracking gives you a lot more freedom and dexterity in the way you interact with content. With most VR controllers, you have to have a fully open or closed hand. But with hand tracking, you can individually move each finger. Some controllers sort of allow that, but there's a lot of dexterity with hand tracking. And that's really important for training in things like engineering, maintenance, or medical training. And hand tracking also allows you to train your staff, or allows people who are learning to use either virtual tools or real tools. So they might be using a screwdriver, scalpel, or even a full virtual dashboard or cockpit. Hand tracking can support all of that. There are also some conditions in which controllers are just not suitable. So this example here is someone using augmented reality to complete a maintenance task. And when you're doing that, picking up and putting down controllers just isn't really very feasible. So with augmented reality in particular, hand tracking is really important for practicality. In fact, the best thing to do is to have multimodal input. So if you have eye tracking, hand tracking, and voice commands, then that's really accessible to a wider range of users. Also those with different access needs as well. And when you use Unity to create content for the HoloLens, you actually can use all of those different input methods. Also, hand tracking is more intuitive to most users than controllers are. And that's really important in virtual reality, because when you're completely immersed in VR, of course, you can't actually see the controllers. You can only see the virtual representation of them. And that can make it quite challenging for a new user who doesn't have any experience with controllers. But in contrast, when you're put into virtual reality, one of the first things people do is reach out their hands. So if you can allow people to actually interact with their hands, it's very natural, it's very universally intuitive, and it doesn't depend upon previous experience. The final thing is that hand tracking increases immersion. And that is really important for you if you're creating artistic experiences or emotional experiences. It's also really important in industry in terms of training, because immersion reinforces learning and retention. Studies have shown that VR-based training results in about 20 to 30% better performance compared to traditional training methods. So training staff in VR means that they remember things more quickly, more easily, they make fewer mistakes. And that's why a lot of industries are now very interested in virtual reality training. So if that's something that you have the skills for, there's a really high need for VR developers in that area. So hand tracking has a number of benefits in terms of VR and AR experiences. So if you want to develop an experience, which includes hand tracking, the first thing you need to decide is which hardware solution is best for your needs. So now I want to show you just a few of the hand tracking enabled different platforms or tools that you could use in combination with Unity, and to show you what you need to get started for each one. So the first one I want to touch on is an augmented reality headset. It's Microsoft's HoloLens, or their HoloLens 2. These have a transparent display, so you can see the real world, and you can also see virtual content augmented on top. Unity have been working with Microsoft since the release of the first HoloLens in 2016. And actually, Unity powers 91% of HoloLens experiences. So I really recommend it if you're interested in head-mounted AR. The HoloLens 2, which came out in 2019, recognizes different gestures, as well as eye tracking and voice commands, as I mentioned earlier. So if you do have a HoloLens and you're interested, or you can obtain one or borrow one, and you're interested in developing in Unity for it, you need to get the Mixed Reality Toolkit, or the MRTK, which is an open source development kit. And you can get that from Microsoft's website. I've put the link here. I'll post all the links in the chat at the end, so don't worry about screenshotting these slides. And then once you do that, you just develop the scene in Unity like you would any other kind of content. And then you can deploy it to a HoloLens. But if you don't have access to one, there is a workaround. You can actually deploy it to a HoloLens emulator on your computer. So if you'd like to develop skills for developing on AR headsets, but you don't have access to one, there are ways around that, and you can develop those skills. The next one I want to touch on is the Quest, or Quest 2 from Facebook, which is a very popular choice. I'm sure some of you have them. It's also very popular in industry because it's tetherless, it has integrated hand tracking, and it also has a very accessible price point. So to use Unity to build for the Oculus Quest, you just need the Unity Asset Store, which comes with the editor, and you find the Oculus integration package. Before you import that, it's really important to check all the versions. So I recommend looking at the latest documentation, because as I'm sure you know, everything in VR and AR is constantly changing. So once you have that package, you just follow a few simple setup steps. Again, you just develop your content in the Unity editor like you would for any other device. Now, both of those examples are specific to just one headset, and they use inside-out tracking. They have a camera on the headset looking at the hands. But there are other solutions which you can use across a number of different headsets. So Manus is a company that specializes in finger tracking wearables. And if you have their hardware as well as their software, you can then combine that with really any of the popular headsets. So to do that, you would need one of the gloves like a Manus Prime 2, and then their Unity plugin, as well as their core software, which is called Manus Core. And once you do that, again, you just develop in the Unity editor as you would any other kind of content, which again, I'll show at the end. And finally, I also want to talk about Varjo. If you haven't heard of Varjo, they're a very high-end manufacturer of hardware and software. They have amazing headsets, which are super expensive. They're more kind of pitched at enterprise than a kind of individual developers. They have photorealistic video pass-through. That's really interesting because on the HoloLens, you have a transparent display, so you can see through it. And on the Quest, you can't actually access the video pass-through. So you can only make fully virtual content, or you can use a transparent display. But with a Varjo, you have very accurate video pass-through. So you can use that to create truly immersive content, which is why the term XR is appropriate. It sort of blends virtual and augmented reality, and it sits on the borderline of both. And then the final and the cheapest option that I want to talk about is the Leap Motion controller, which is this camera here. Some of you, if you're familiar with VTubing or very interested in avatars, you may have heard of Leap Motion. So a few years ago, Leap Motion merged with a company called Ultra Haptics, and they formed a new organization called Ultraleap, where, for full disclosure, I worked for a year. So as well as being integrated with some headsets, like Varjo's has integrated Ultraleap hand tracking, they also have these standalone camera modules, which you can obtain on eBay. You can find them secondhand fairly inexpensively. And you can use that in combination with Unity to easily add hand tracking to your application. So what are people using hand tracking for? Well, again, I work in industry, so there are almost an infinite number of things you could do with it in terms of arts and creation. But it's interesting to know that this is being utilized in industry as well. One of Unity's big clients is Toyota, the world-leading car manufacturer, and they used Unity in combination with the MRTK to develop content for the HoloLens 2. One of the problems they had is that they want to explain what's happening inside a car after it's been assembled, which is quite hard to visualize. So they created content that allows users to walk around the car and look kind of virtually inside it, even looking at mechanisms that only occur when the car is moving. And they overlaid that onto a real stationary vehicle, making something that would have previously been impossible to perform very easy. The user can interact with the virtual dashboard, they can accelerate the car, stop it, and then they can see what impact that has on the internal mechanisms. Hand tracking is also really useful in terms of AR-assisted repair and maintenance, which is another HoloLens-based example. This is a company called ABB, who are a supplier and repairer of industrial machinery. And essentially, when their field operators go out on site to fix something, they are doing quite an expensive and time-consuming procedure. They're working with very dangerous and expensive equipment, so they need a lot of training. So what ABB did is use Unity to create an application that walks the user, the field operator, through the steps and allows them to check off each step as they go. And that not only reduces errors, but it also means that they can track which engineer is doing what in real time, which reduces communication errors and also sends back all of the data in real time to their HQ. So that solved a lot of communications problems for them and saved them a lot of money. And then the final use case I want to touch on, which I think is one of the most interesting, which I've seen a lot in gaming, but not yet in industry, is communicating with sign language. There's a community of deaf users in VR chat. And VR chat, for those who don't know, is a multiplayer VR social platform, which is created in Unity. And those users use hand tracking to communicate in sign. They're also inventing new kinds of sign language. And there are, in fact, whole virtual worlds dedicated to teaching hearing users how to sign. And because of the very precise movements that are possible with hand tracking, you can do a much wider range of signs than you would be able to with controllers. Especially, that's really important for deaf users in VR because you also can't easily necessarily, no one can type on their keyboard while in VR. And you also can't see users' lip movements. So having that communication is really important. There are some particular signs that are still challenging due to hardware limitations. So the sign L in British Sign Language is this, and it's quite hard for a VR headset to see the sign because you're occluding it with your hand. But a lot of users are now creating new signs specific to VR, which I think is amazingly interesting and one of the best use cases I've seen. So those are some quite different use cases. Hopefully you now have an idea of some of the hardware available and what you might create for hand tracking and how it can benefit you. So now I want to show you how simple it is to include hand tracking in your demo without any need to code whatsoever. Now you can use any tool you want, but I'm going to use this Ultraleap standalone camera for this demo. And because I wanted to build a car-specific demo, I'm going to use a template, which is called Unity's Auto Showcase. But you don't need to use that. You can just use a blank Unity project and you can follow exactly these same steps. Hopefully this is high res enough. So the first thing you need to do is just start a new project in Unity, which you do by opening the Unity Hub, clicking the down arrow to choose an appropriate version of Unity. So for this project specifically, I wanted to use Unity 2019 4.20. Then you just choose a save destination and a name. Now, if you're doing a car-specific demo or you want a high-definition kind of gallery to use, we have this HD sample auto showroom, which you can access here. And it's available completely for free to anybody. So I highly recommend looking at that if you're interested in using that environment. But again, you could just start a plain Unity project and that will also work perfectly fine. This project specifically comes with tutorials, but for now, I'm just going to close them. And it also comes with this tutorials window, but again, we don't need that right now. And I'm going to put my game view and my scene view side by side so you can see what I'm doing. So the first thing you want to do is obtain Ultraleap's hand tracking modules for Unity. To do that, you just open up a web browser and go to developer.leapmotion.com/Unity, or just Google Unity Ultraleap, and that will be the first result. Then scroll down and download the appropriate version of the Unity modules. You'll need a Leap Motion developer account, which is completely free to get, and then just sign in with that account. Once it's downloaded, just locate and unzip the folder, and you'll find 3 Unity packages. To import these into the project, just double-click them, and then click on Import. We're going to do that with each package in turn. So Core, then Hands, and then Interaction Engine. If you get any weird glitches and the project isn't displaying, if you just click Play and then stop it, it should refresh the windows and it will start displaying correctly. In Unity, you can zoom in with the middle mouse button, and then you can hold the middle mouse button down to pan around as well. I'm just going to auto fix some situation here. So now we basically have everything we need. And the next step is to set up hand tracking in the scene. So in order to do that, I'm going to right click in the hierarchy, which is the window on the left, and create an empty game object. And I'll call it hand parent. Then search the project window for the hand model manager and drag and drop that onto hand parent. Then search again for Leap service provider and do the same, drag and drop. Then we want to search for low poly hand rigged left, and then low poly rigged hand right, and drag those onto the hand parent in the hierarchy. If I zoom in, you can see they look magenta. That's because this is a high definition scene and I just need to update the textures. So if you do need to do that, just expand each hand, click on the mesh, and then over on the right in the inspector, find the shader, expand that field, and then select HDRP lit. So if I do that, you'll see these hands now appear correctly in the scene. That's specific to high definition projects. To hook up the hand tracking, you just click on the hand parent, look at that hand model manager component, and in the field that says Leap provider, click hand parent. Then expand this model pool field, and in the size, enter 1 and hit enter. And now just drag each hand from the hierarchy into the field that says left model and right model respectively. Make sure you drag the low poly rigged hand object, not the mesh that is childed to it. Then just make sure is enabled is ticked in the inspector. And then finally, if you want to reposition the hands, make sure you move the hand parent empty object around rather than the childhood models. So we can press E to rotate, and we can also press W to reposition it, to move it around using these arrows. I'll just get them into position. And now if you press play, hand tracking should work, and the virtual hands should match your real hand movement. And it's as easy as that. You can see that the hands are in a good position, but the game view doesn't reflect that. So to do that, I'm going to add a new camera by right-clicking in the hierarchy and clicking camera. And with that camera selected, if you go to game object and align with view, this matches the camera's view to your scene. And from here, you can add any kind of interactivity you want. You could add buttons, and you could add a dashboard. I'm going to just pause my demo there. So just to prove to you that obviously I had to fast forward some parts, so that's a sort of pre-recorded segment. But just to prove to you that this truly is live, I'm going to open up the project. So for this demo, I also added a mirror. So you'll be able to see once my hands are going. There we go. So my hands are reacting in real time. And I also added this mirror here because I thought it would be interesting to show that you could use virtual reality to test visibility in a car, for example, which is something that industrial users are very interested in. But of course, if you create artistic applications and you're more interested in adding hand tracking to your avatar, or to have a painting game where you paint with your hands, or anything you can think of, you can add hand tracking in this way, and it should work perfectly fine. So that was a lot of information. But if you would like to, oh, I've just realized I'm still sharing my Unity project. 1 second. Let me switch over back to my slides. There we go. So I realized that was a lot of information. But if you would like to get started and you want to read more about the documentation, then these are the 3 relevant links. Again, I'm very happy to post these in the chat. And if you would like to get in touch with me or know more, then you can find me on Twitter. You can also find me on LinkedIn. Very happy to connect on there. And I would love your feedback about this talk and about what I'm doing in general. So yeah, particularly if you have any feedback about this talk, do please follow the link. I love getting your feedback. And hopefully I will come back here again. I'd love to learn what you're interested in learning about. Thanks a lot.
Antonia, thank you. Thank you very much. Big round of applause in the chat. Yay. And Antonia, obviously, of course, is part of our group, which is what this, oh God, I'm dying. What this is all about, really. It's our community, and we're all part of it. So yeah, so thank you, Antonia. I am going to close this down. We're going to come back in a couple of minutes, and we've got Anya talking about her project, and I can't wait for her to showcase this. Actor performer, learning Unity and development, and then putting something out onto SideQuest and distributing it and learning along the way. So she's going to talk about her journey for the next 20 minutes. So Antonia, thank you very much, and I'll see you all in a minute.